So in this session of basic mathematics for physics, we'll continue the topic of trigonometry part B. So in this session, we'll start. In the previous session, we talked about trigonometrical ratios for different angles like 30 degree, 45 degree, 60 degree. In all the cases, we are talking about angle in degrees. But in case of physics, it's more common to use a radian as a measurement of angle or unit of, we measure the angle in terms of radian. So let's first understand what is this radian, because many of you are not too familiar and you have little difficulty also what is angle in radian mean. Angle in radian means angle subtended by arc on its by arc of a circle on its center. So let's say this is circle here. You can see the circle in the dotted line. O is the center of the circle, R is the radius. And what we see in the blue color, this is an arc of a circle. This is an arc of a circle. And this arc of a circle makes an angle at the center. So how do you get this angle? Two ends of the arc, this end also is covered connected to the center. Other end of the arc also, this also connected to the center. Now we have two intersecting lines and this angle formed here. This angle theta, we typically measure the angle in terms of degree. If we have to measure this angle in radian, how would I obtain this angle theta in radian? That's what we need to understand here. To find this angle in radian, what we need to do, we need to find the length of the arc, which is like this. What is the length of the arc? If I divide by radius, the ratio what I get will be equal to angle theta in radian. So any arc makes an angle, and to find that angle, we need to divide the length of the arc by the radius of the circle. And measurement of length of the arc is not easy, because we are used to measuring things which are in a straight line using a scale, but anything which in form of an arc is not so easy. So let's take another arc which is a little easier to measure. What is the other arc we take? Let's take the arc which is a red in color. It starts from here and ends here. So here also what you'll do, if you have to find the angle, this end is already connected to the center. Other end also is connected to the center. And so basically this angle now is forming. So not this theta, now what is the theta we are talking about? This angle theta we are talking about. And if I have to measure this angle in degree, I think we immediately recognize what this angle is. This angle is, two lines are mutually perpendicular. This angle is 90 degree. But I don't want this 90 degree. I want this theta in a radian. What do we need to find this angle theta in radian? I need to find the length of this arc here. It's not easy to measure, but we have some mathematical formula which you can use here. What is this arc length equal to? So this theta is equal to 90. And so we are finding theta not in degree. Now we are finding theta in radian. So what we need to do, we need to find the length of the arc. This length of the arc, this part is 1/4 of the perimeter of the circle. And we know perimeter is equal to 2 pi r. So it will be 1/4 of 2 pi r, which is equal to pi r by 2. So we, from our mathematical formula, we know the length of the arc. If we divide by radius, I'll get this angle theta in radian. So what is this angle theta? The theta is equal to pi by 2 radian. So what we understand here, 180 pi by 2 radian is equal to 90 degree. Or you want to do in terms of 180 degrees, since if we don't like anything coming in the denominator, this is the relationship we can use. Pi radian is equal to 180 degree. So 1/4 circle is equal to 2 pi radian, half a circle is equal to pi radian, quarter is equal to pi by 2. And if we say like 30 degree, 30 degree will be equal to pi by 6, 1/3 of 90 degree. Also 1/3 of pi by 2, 30 degrees pi by 6. And 60 degree will be equal to pi by 3, 45 degree will be pi by 4. So those very simply, you can, from this relationship, you make different divisions, you can get those numbers. For different radians, we can get the corresponding degrees. So, okay. Now we move on to next part here. So in this case, we are going to find trigonometrical ratios for angle greater than 90. Previous case, we have used a right angle triangle, acute angle of the right angle triangle. Hence, the angle cannot be greater than 90. It has to be less than 90. So here we use something else, not a right angle triangle. Some other way, some other technique we are going to use to define angle, so that we can have angle ranging from 0 to 360, and we can have corresponding ratios also, sine, cos, and tan. So this is the figure we are going to use. So let's see how it is useful here. So in this figure, what we do, this is positive x-axis. So if I look at this, what's this? First, before I start, this is positive x-axis. If I take this direction, this is negative x-axis. This is line segment, this is positive x-axis, the y-axis. We take a line segment OP, this point O and this point P here. We see this endpoint here. The line segment OP, and how it is placed now. Right now, this line segment is placed along x-axis. It is same direction as plus x-axis, or I can say it is making a zero angle with x-axis. If I make this line segment rotate about O, its angle with x-axis will keep on changing. How the angle will vary, let's visualize what will happen. So what we are doing, we rotate in which sense? In physics, typically we rotate in anti-clockwise, we take that as positive. So which direction? Clockwise is this sense, we are going to rotate in this direction, anti-clockwise direction. It will rotate like this. Let's visualize this rotation and see how it will rotate and how the angle will change. So just like a needle of a watch, this will rotate. Let's make it rotate. Started rotating, it has come to 90 degree. Increasing further 180 degree, 270 degree, and 360 degree. So what do you understand here, and how are we measuring the angle? We are measuring the angle line OP makes with the positive x-axis. So as and which point is moving, so we can think of motion of the line segment. We think of the motion of point P. Point P is moving on the perimeter of circle of unit radius. We have taken the OP to be 1. So what is this length from here to here? This length is 1. So the 10 division, each division is equal to 0.1 unit. We have drawn a graph also, which will be a little easier to make things understand. So as it completes one full rotation, the line segment makes angle starting from 0 up to 360. So it makes a first quadrant. As it starts rotating, passes to first quadrant, second quadrant, third quadrant, and fourth quadrant. They come in the order of rotation. That's why 1, 2, 3, 4. And this is a common notation we use here. First quadrant involves angle from 0 to 90. Second quadrant 90 to 180, and third quadrant 180 to 270, and fourth quadrant 270 to 360. But many times what we do, see here, what is the sign convention we have taken? We have taken theta to be measured positive in this direction. This direction theta is positive, which means if I go in the opposite direction, theta will become negative, angle will be negative. So another way, if I measure angle in this direction, it will be negative. So very often what we do, anything which in the fourth quadrant, we measure the angle in anti-clockwise sense, and we measure the angle magnitude with negative sign. We'll come to that part also again. So when we had 270 degree can also be written as minus 90. 270 degree can be written as minus 90 and so on. Okay, because in that case, I'm measuring in the clockwise sense. So let's see how it is useful now. So to understand, we have taken a random position. It has moved, point 2 has moved up to this point here. And how do we define? At a particular instance, this angle be theta. So at this point, what is the angle this line segment is making? Is making angle theta. And point P has moved to point P1 here. Okay. So from here, if I drop a perpendicular, base of the foot of the perpendicular is M. Now we have a right angle triangle. And we have angle theta, we have right angle triangle. If we know the sides of the triangle, we can find trigonometrical ratios for angle theta here. The right angle triangle, so let's use what we have understood in the previous session. So what will sine theta be equal to? Sine theta, sine of any angle is equal to opposite side by hypotenuse. So sine theta will be equal to P1M by OP1. But OP1 we have taken as 1 unit. We have taken a circle of unit radius. So denominator is 1. So sine theta becomes equal to P1M. And P1M is nothing but y coordinate. And let's understand, as some of the people may not be comfortable finding coordinate. If this is a point P1, how do we find the coordinate? We drop a perpendicular on x-axis. The foot of the perpendicular is M. So x coordinate of this point is x coordinate of P1. Similarly, if I drop a perpendicular on y-axis, so foot of the perpendicular on y-axis, y coordinate of the foot of perpendicular is y coordinate of P1. So in this case, if I have to write coordinates of P1, x coordinate is equal to 8 divisions. Each division is equal to 1 unit. Hence, it will be equal to, each division is equal to 0.1 unit. 10 division is equal to 1 unit. So 8 division will be equal to 0.8. and y coordinate 1, 2, 3, 4, 5, 6 will be 0.6. This is just to make you understand how x and y coordinates are. So what is P1M? P1M is equal to, and reason is very simple. If I draw a line like this, all this point y coordinate is same. So y coordinate of P1, we are finding another point on the y-axis which has same y coordinate as P1. So this becomes the y coordinate of this point is equal to y coordinate of P1. X coordinate of this point is equal to x coordinate of point P. Okay, so why it is relevant here? How is coordinate related to trigonometrical ratios for cos angle theta here? Let's understand. So what is sine theta? Sine theta is equal to P1M, and P1M is nothing but y coordinate. So what we understand here, as the point P rotates here, its angle keeps changing, its coordinates keep changing. But this angle, sine of this angle is related to corresponding y coordinate. Similarly, let's find cos theta. Cos of theta, so this theta will be adjacent side. This side becomes adjacent side by hypotenuse. So that will be OM by OP1. OP1 is 1, so it is equal to OM. OM is nothing but x coordinate. So x coordinate of P1 is equal to cos of theta. So if we understand this point here, what I'm saying here, see here in this particular case, actually, so which is the x coordinate? 0.8 is x coordinate, which is equal to cos of theta. 0.6 will be equal to sine of theta. So if we can measure this angle theta, we can find for that angle, we can find cos theta and sine theta from this figure. Okay. So, and we can also, just to understand a little bit more, in first and second quadrant, y coordinate is positive, and since y coordinate is equal to sine theta, it means in first and second quadrant, sine theta is positive. Or we can say for angle 0 to 180, sine theta is positive. 0 to 180, it is positive. How about cos theta? Cos theta depends on x coordinate, and x coordinate is positive. Which half? Right half is x coordinate positive, upper half y coordinate is positive. What does right half mean? Right half means first quadrant and fourth quadrant. First quadrant means 0 to 90, and fourth quadrant, Q4 can be written in two ways. We are saying very commonly we refer in two ways. Either I can write as 270 to 360, or I can measure Q4 in the other direction. We can measure in negative sense. So that will be equal to 0 to minus 90. Okay, so this line will be minus 90 also. So corresponding to 270 minus 90, corresponding to 360 is 0. So this angle can be negative also in fourth quadrant. So theta is, cos is positive 0 to 90 and 0 to minus 90. And cos sine theta is positive 0 to 180, remaining part it is negative. Okay, so what are the key points we learn from this particular side? As the point P moves on the circle of unit radius. Any position of point P, for any particular position of point P, it will have certain angle, it will have coordinates, and these things are related. So any point P is angle it makes and coordinate it has are related. What is the relationship here? The x coordinate will be equal to cos of the angle it makes at that particular instant, and y coordinate will be equal to sine of the angle it makes at particular instant. So we just get a mental picture of the figure what we have here and how x and y coordinate are related to sine theta and cos theta at a particular instance. And this is something what we're going to learn to apply in subsequent side and see how it is useful. Okay, so basically what we have seen here, let's do something more. Each division is 1 unit. What are coordinates of points? So we'll mark various points on the circle. Let's take this point P1. See, we are talking about 3 things here. What are 3 things we are talking about? Angle, x coordinate, and y coordinate, and they are related. So let's see how they are related. Let's see, in this case, angle theta is equal to 37 degrees. So the theta I have drawn such that this angle is 37 degrees. So can we find coordinates of coordinates and angle of point P1? So let's do for P1. So 3 things we are going to find. What is the angle it makes, theta? What is the x coordinate? And what is the y coordinate? Hence, what will be sine of that angle and what will be cos of that angle? Can we do that also? For point P1, what is the angle theta? Already written. This is 37. No problem. This is given here. What is the x coordinate? I drop a perpendicular on the x-axis. This is the foot of the perpendicular, and x coordinate of foot of perpendicular on x-axis is equal to 8 unit. Each unit is 0.1. Each division is 0.1 unit. So how many 8 divisions? So it will be x coordinate will be 0.8. So I write x coordinate is 0.8. Similar way, y coordinate I measure, I drop a perpendicular on y axis. If I drop a perpendicular, this would be the foot of the perpendicular. And what is the y coordinate? 1, 2, 3, 4, 5, 6. Each division is 0.1 unit, so it will be 0.6. Y coordinate is 0.6. So what will be sine of 37 here? Sine of 37 will be equal to y coordinate. Sine of 37 is 0.6 and cos of 37 is 0.8. So we are learning, but basically the idea is to relate angle and coordinates. So this is one. Let's do some more. Let's do the point P2. So similar way, let's repeat for point P2. And you know, the P2 has some special things. We notice this P1 here. If I actually complete a triangle here, what we notice here, y coordinate of P2 is same as y coordinate of P1. And similarly, the distance from the origin along axis also same. So can we find the angle P2 makes? What is the angle P2 is making with the x-axis? How do we measure the angle? See, when we draw the angle arrow, we start the measurement of angle from here, and we draw it something like this. We continue this rotation till we reach the line. This is the angle we need to measure. Okay, if this is 37, very easily you can notice this angle also is 37. So what is this angle here? This angle is 180 minus 37. This up to here it was 180. Since this angle will be 37, because here, so basically what is happening, this triangle, what gets formed here, is identical to this triangle here. Okay, the height and base lengths are equal, hypotenuse also equal. So this angle also will be 37. So the angle P2 makes with the x-axis will be equal to 180 minus 37. So let me write P2. What is the angle 180 minus 37? I can write like this also. We can simplify, or we can write like this. So can we, and this is something part of it, but you can do that. You can pause the video and you can put this value yourself before you see what we had done here. Okay, but I will continue. You can always pause the video. Whenever I ask a question, you can pause the video, try and find the answer yourself, and then check what have you done. Was it correct or not? X coordinate, again from here I drop a perpendicular. This is the foot of the perpendicular. So this point 1, 2, 3, 4, 5, 8 divisions. Lengths are equal. So this was plus 0.8. This will be minus 0.8. So position of point 2, x coordinate will be minus 0.8. And y coordinate is same as P1, which is equal to 0.6. So basically what is this angle comes to? So sine of, if I have to calculate, sine of 180 minus 37 is equal to what? Sine of 137 is equal to y coordinate, which is equal to 0.6. And cos of 180 minus 37 will be equal to x coordinate, which is minus 0.8. Of course, cos is negative in the second quadrant. So there are two, basically what we notice, see, in case also, the sign has changed, magnitude of x and y coordinate has been changed. And magnitude has remained same. So there are two more points which have same magnitude of x coordinate and y coordinate, though the sign may be different. So can we think of another 2 points here? Can you mark those 2 points in the circle? And can you think of what will be the theta, x and y coordinate and all? Okay, so if not, let's do P3 is the third point. And what is the angle it makes? Angle, again, to measure the angle of this line, I start a kind of measurement arrow starting from here. Keep rotating, yeah, we visualize the rotation till I reach this point. This angle I need. What is this angle here? We know this angle, see, this triangle and this triangle. Basically, you know, this angle and this angle are opposite angle, they are equal. This angle is 37. So this total angle actually will be equal to 180 plus 37. So you notice some kind of pattern here. This angle was 37. Then another point which is having same magnitude of x and y coordinate was 180 minus 37, 180 plus 37. So this angle I'll write as 180 plus 37, or maybe for a change I'll write yeah, 180. So let me write only 180 minus 37. So again, can we quickly write what is the x coordinate? X coordinate of P3 is same as x coordinate of P2, which is equal to minus 0.8. And it is in the third quadrant, both are negative. So y coordinate also is minus 0.6. So basically you can fill up this value also. Sine of 180 minus 37 will be equal to y coordinate minus 0.6. And cos of this angle will be equal to minus 0.8. Similarly, there's one more point here. P4. And for for a change, what I will do now, P4 also, this angle is 37, and this angle also, if I measure like this is 37. But since I'm going in a clockwise sense, starting from x-axis, I'll write this angle as minus 37. So this angle is minus 37. Fourth quadrant, very often we take angle, we measure the angle in a clockwise sense, hence we put a negative sign to whatever angle we measure. So minus 37, and what are the x and y coordinates here? Very easily can measure. We can drop it. To measure x coordinate, we drop a perpendicular on x-axis, measure the coordinate. This is equal to plus 0.8, and y coordinate will be minus 0.6. So what is the sine of minus 37? Sine of this angle at this point will be equal to y coordinate of this point, which is equal to, what is y coordinate here? Minus 0.6. And what is cos of minus 37? Cos of minus 37 will be equal to x coordinate at this particular point, which is equal to 0.8. So this is just to practice this one, get a understanding of angles, how the angles are measured, and how the coordinates are measured, and how are they related to each other. We'll repeat the same thing in a more general sense. So far we have done a specific angle. Now we'll do in terms of angle theta and in terms of variable form. How are the, and when we do in variable form, it becomes a formula. So what we have done, actually it can be converted into finding angles in 4 different quadrants. You notice what we have done here, like doing like this, we have found angles, we have found sine and cos of angles in 4 different quadrants, and they are related to each other. So that's what, and if you do so, it becomes like a formula. So let's do what we had done in the previous slide for a general angle theta, so that it becomes like a formula. So let's find those relationships. So this is the point one on the circle, which makes an angle theta here. So there are 3 more points which will have same. See, if we take up what are the other 3 points which will have same magnitude of xy coordinate, these are the 3 more points. So all 4 points. So if this angle is theta, from here this angle also will be theta, and from here this angle is theta, and from here this angle is theta. So all these 4 points you can notice from the graph also. So this particular point has x coordinate of 8 units, y coordinate of 6 units. So here also it will have, say, x coordinate of 8 units, but negative value, y value is positive. So all 4 cases, basically the magnitude of xy coordinates are equal, and that helps in finding relationship for trigonometric ratios corresponding to these 4 points. Let's find what those ratios are. So if this angle is theta, what is the angle line OP2 makes with the positive x-axis? How do you find angle? See, angle of a line, what is the convention we are using? We are measuring angle from starting from positive x-axis, and we rotate in anti-clockwise sense. So it is like this. We draw the angle like this. Now we visualize the angle like this. So this is the angle for point P2, and this angle will be equal to 180 minus theta, or in terms of pi, let me write this angle will be equal to pi minus theta. So theta, pi minus theta, this particular angle will be pi plus theta. So for point P3, it will be like this, and this total angle will be pi minus theta, beside pi plus theta. And fourth one, I think this one I mentioned earlier also, we can measure this angle in clockwise sense. So this magnitude is theta, but sine is negative. So this angle will be minus theta. So what are the angles? Let me write the angles again. This point angle is theta. This point angle is pi minus theta. This angle is pi plus theta. And this angle is minus theta. So these are 4 points, and there's a definite relationship between cos of these angles and sine of these angles. Let's find those values. So let's find it for y coordinate. So point 1, and this would be the y coordinate. Let me call this as y1. So this coordinate is y1, and y1 will be equal to sine of this angle of p1. y1 will be equal to sine theta. So let's, a similar way, let's find the relationship here. For this, what would be sine of pi minus theta? Sine of pi minus theta will be y coordinate of p2, and y coordinate of p2 is same as y1. Hence, I can write sine pi minus theta is equal to sine theta. And you notice here, it also makes sense that this is positive, this are positive, so both are equal to each other. Similar way, let's find for point P3, angle is pi plus theta. So sine of pi plus theta will be y coordinate of this point, and y coordinate is negative here. Hence, we put is equal to minus sine theta. Third quadrant, sine theta is negative. And you look at this otherwise also. Above this line is positive, y coordinate. Below this x-axis, it is negative. So there's this the value of sine positive, positive, negative, and negative. So here also it has come positive, pi minus theta positive. Third quadrant negative. Similarly, fourth quadrant also, this angle is sine minus theta. It's a negative value minus sine theta. Actually, sine theta stands for y1. So coordinate of P4 will be equal to minus y1, and minus y1 can be written as minus sine theta. So this is how all angles are related. All angles theta, pi minus theta. Sorry, this should be pi plus theta and minus theta. This is relationship of sine of these angles. Very easy, it makes sense. First, quadrant 1 and 2 positive, and 3 and 4 negative. Similar, we'll repeat same exercise for cos theta. And cos theta also, let's recall, 2 of the cos theta values will be positive and 2 of them will be negative. Angles will remain same. So which quadrant is cos theta positive? Cos theta is positive on the right hand side of y-axis. It is negative on the left hand side of the y-axis. Basically x coordinate. So Q1 and Q4 cos theta is positive. Q2 and Q3 it is negative. So if you write this one, x1 is equal to cos theta. So this particular coordinate of point P, x1 is equal to cos theta. This particular point is negative minus x1. So hence this will be equal to minus cos theta. So cos pi minus theta is equal to minus cos theta, negative value. Same thing for P3 also. For P3, cos of corresponding angle, cos of pi plus theta is equal to minus cos theta. And fourth quadrant, it is see x coordinate of P4 is same as x coordinate of P1, which is equal to x1. So cos of angle of P4, angle is minus theta. So cos of minus theta is equal to cos theta. So again, we look at this here, sir, which two are negative. This is Q2 and this is Q3. These two values are negative and Q4 is positive. And this these two are most very commonly used. Sine of minus theta is equal to minus sine theta, fourth quadrant, and cos of minus theta is equal to cos theta. Okay, let's again check this one. We'll take one more angle just to understand this point here in terms of number. Those are we done in terms of variable. So we have drawn this angle exactly at 30 degree. So this if we have drawn this angle at 30 degree. So let's find what is the x coordinate and y coordinate. Y coordinate comes up very kind of clearly on this particular line, which is 5 units. So y coordinate of P1 is 5 units, which is equal to 0.5. So y1 is equal to 0.5. And y1 is equal to sine of that angle. So sine of 30 is equal to 0.5. So theta angle, I have drawn it exactly at 30 degree. So from the graph itself, that's how we can find those values. So again, we had drawn the circle of radius of 1 unit. So at any particular point, y coordinate is sine of that angle and x coordinate is cos of that angle. So similar way, and what will be x coordinate here? X coordinate is it comes something a little more than 8.5, actually something like 8.7. So since one division is 0.1, x1 will be equal to 0.86 or 0.87 in that range, and which is actually this is the value of √3/2. So you look at this, if we plot this graph properly, if we draw the angle properly, from the graph itself, we can find the value of cos theta and sin theta. Also, this angle theta is 30. Okay, and which are other points which will have same magnitude of x and y coordinate? P2, P3, P4. These are the 4 points on the circle which have same xy coordinate, though the sign will vary. What are those angles be? What will the angle of P2? If this angle is theta, this angle P2 will be pi minus theta or 180 minus theta. So the P2 will be 150 degree. So if I measure this angle, 150 degree, and this angle will be equal to, for P3, again, if you measure the angle from here, this angle is 30 plus 180. So it will be equal to 30 plus 180, 210 degree. And this angle will be minus 30 degree. So all of them have same magnitude of x and y coordinates. So their sine values and cos values are related. Can we find the relationship? So x1 cos 30 is equal to 0.87. We have written already. Y1 will be equal to sine 30, which is 0.5. We can read it from the graph. So there are 4 points here, which are the 4 points? 180 minus 30, 180 plus 30, and minus 30. That's what he written here. These are the 4 points which will have. So can we find that what is sine of 150? So if we draw this angle, what is sine of 150? Sine of 150, y coordinate is same as P1, and sine of 150 will be equal to sine of 30 itself. What will be cos of 150? Cos of 150 will equal to minus cos 30. Then you can again look the x coordinate of P2 is negative of x coordinate of P1. Hence, corresponding cos value, cos of 150 is equal to minus of cos 30. When we go to point P3, angle is 210. So here, in terms of sine, y coordinate of P3 is minus of y coordinate of P1. Hence, sine of 210 is minus sine 30. And cos value, x coordinate of P3 is negative. It is equal to x coordinate of P3 is equal to minus of x coordinate of P1. Hence, the corresponding relationship between cos of these angles, cos of angle for P3 will be equal to minus of cos of angle for P1. So, which is equal to, we can write cos of 210 will be equal to minus cos 30. And this particular point, sine of this angle, y coordinate is negative, y coordinate of P4 is equal to negative of y coordinate of P1. So if we write corresponding angle sine values, sine of minus 30 will be equal to minus sine 30, and cos of minus 30 will be equal to cos 30. So what we have done in terms of theta, in terms of variable, we have also done in terms of a specific angle. So we should be able to find this kind of relationship between angles which are of order of theta, pi minus theta, pi plus theta, and minus theta. Those angles are related. But then we come to graph. Graph will deal with graph in more detail later. So what will be sine theta graph look like? So what we have, so whenever we have this kind of graph, what is there on the x-axis? X-axis is the angle, and y-axis we have plotted the value of sine theta. The shape of sine theta curve is like this. Let's understand also what else we can understand. First of all, how do we get this kind of shape for sine theta curve? And theta, if I write in terms of degree, this one full rotation, this will be 360 degree, one full cycle, or in terms of radian, it will be 2 pi. Half of it here, this will be 180 degree, or you can write it as pi radian. And this will be 90 degree, and corresponding, this will be pi by 2. And this will be 270, so this will be equal to 3 pi by 2. So these are the angles in degree as well as radian. How do you get this shape? Can we understand also how do we get this shape? Again, we can understand the shape from this point moving on the circle. The point, when this point start moving from here, this angle is 0. As this point moves here, this particular point angle is pi by 2. When the point reaches this point, angle is pi, and this particular point angle is 3 pi by 2. So let's understand what is happening. So as it moves, y coordinate is equal to sine of the angle. So as the point moves from here to pi by 2, angle is changing, correspondingly y coordinate is changing. What is y coordinate? Y coordinate is actually the vertical distance of the point from x-axis. As the point moves, y coordinate is increasing. So look at the graph also. As theta changes from 0 to pi by 2, the sine theta also increases from 0, and it reaches a value equal to 1. So what is this value here? It reaches a maximum value of 1 when theta is equal to pi by 2. What happens after it crosses this point? Now here again its distance from x-axis start decreasing, or its y-coordinate starts decreasing, and corresponding to this motion here, the graph here is from here to here. So this is the second quadrant. And you notice again, first and second quadrant, sine theta value is positive. So here also this is positive value. This is positive value. As it enters the third quadrant here, the y coordinate has turned negative, and it gets more and more negative value. It reaches -1 here when it reaches 3 pi by 2. So this is the corresponding part of the graph. From here, if from 0 it turns negative, and when the angle reaches 270 degree, it has become -1. So if I mark this point here, this particular point will be equal to -1. And as it moves from this point to this, we can again visualize how the y coordinate is changing, or how the distance from x-axis is changing. It is changing from -1 to gradually 0. This is the corresponding to fourth quadrant. So if I mark, this is Q1, this is Q2 part, this is Q3 part, and this is Q4 part. Positive, positive, negative, negative. This is much better way of understanding and getting a mental picture of how the value of sine theta changes with the angle changing from 0 to 360 degree in, or 0 to 2 pi radian. What would happen to cos theta? Cos theta will change as x coordinate. When it is here, x coordinate is equal to 1 unit here. As you start moving, x coordinate is distance from the y-axis. X coordinate is distance of the point from the y-axis. So as the point moves from here, by the point when the point reaches this particular point, when angle becomes pi by 2, its x coordinate has become 0. From 0 to, so when angle changes from 0 to pi by 2, cos value changes from 1 to 0. So when you look at the graph also, corresponding to when theta is equal to 0, value of cos theta is equal to 1. This is +1. And as the angle reaches pi by 2, value of cos theta has become 0. It gradually reduces. So as it keeps moving, we can draw this one also. What happens, this part of is value in Q2, it moves like this. So value is getting more and more negative, and when the angle is pi radian, it has become -1. And this is the corresponding part of cos theta curve for the Q2. So again, this is Q1, Q2, Q3, Q4, same as earlier. You notice this Q1 is positive, Q2 is negative, Q3 is negative, and Q4 is positive again, which we had seen twice in the previous slides. So you should be able to understand how this graph has been drawn, and we should be able to understand and interpret this graph as well. See, understanding graph is important part of understanding physics, and the sine curve and cos curve is useful in several chapters of physics. And how do we visualize? So you should be able to relate motion of a point or motion of a line segment, rotational motion, starting from 0 angle to 360 degree, how x and y coordinate changes, similar way cos theta and sine theta changes, and the change of those sine theta and cos theta vis-a-vis that angle theta, we should be able to convert in form of a graph, which is shown here. Right, so this kind of motion. This is something in this motion you should visualize, see how x and y coordinates are changing. Right? Let's move on to some more formula. We will not go into derivation, but there are a few formula we must memorize. And which are the two formula we must memorize? Sum of two angles. So here, so far we have dealt with sine of a particular angle. What if it is sum of two angles? A also is some angle and B also some angle. It can take any value. Sine of A plus B is equal to sine A cos B plus sine B cos A. And cos of A plus B is equal to cos A cos B minus sin A sin B. And this derivation is not so simple, so we are not going to go for derivation. But these two formula, again, they are like 3-star category, 5-star category, whatever. So this also be very important. It must be part of your permanent memory bank. You should never forget these two formula. And from this formula also, it can have multiple usage. First, you memorize this formula, and as we go along, as you go through different parts of physics, we'll come across this application. So we are not going to solve mathematical question based on this. We'll memorize, we'll see some application of it, few applications of it, so that, and it have multiple uses. So many things can be done. So suppose from these two, can we arrive at tangent of A plus B? Yes, it is possible. How do we get this value from these two? What is tangent? Tangent of any angle is equal to sine of the angle divided by cos of that angle. So tangent of A plus B can be written as sine of A plus B divided by cos of A plus B. And then we can write the value of sine of some of these two angles from here and cos also from here. So this will be equal to sine of first angle into cos of second angle plus sine of second angle into cos of first angle divided by cos. How do we write? Cos of first angle into cos of second angle minus sine of first angle into sine of other angle. From here, how do you get to this form here? Here we need 1. So basically, how do you get 1 here? If I, from here, this equation, I need to get into this form. So basically, to get this term as 1, I divide numerator as well as denominator by cos A, cos B. So if I divide this term also with cos A, cos B gets cancelled with cos B. This becomes, this part becomes tan A. So I divided both numerator and denominator by this term. Simple, you should do on your own. It's very easy to arrive at. And this term will be equal to tan B, and this term become 1. And this term divided by cos A, cos B, it become tan A, tan B. So this is also very easily we can arrive at this formula for tangent of sum of two angles can be arrived from these two. Let's do some more. Can we also, from this formula, can we also find out a difference of two angles, sine of A minus B? So same formula, what we can do, we can substitute any value for these two values A and B. What we will do here, in place of B, suppose I substitute minus B. In this formula, I substitute B with minus B. If I substitute minus B, see what happens here. If I substitute minus B, wherever B comes, I need to substitute minus B here. So if I substitute minus B, this will become A minus B. This will become cos minus B. Cos minus B is equal to cos B itself. Only thing what will happen, sine of minus B will become minus sine B. So what will happen if I substitute minus B in place of B? Wherever sine B, A term will remain unaffected. So this term will not change. Sine A and cos A will not change. So what I think, this part will change. This part, wherever B term is coming, those things may change. Cos of minus B will remain same. We substitute in place of sine minus B as minus sine B, and cos minus B is equal to cos B. If I make this substitution, what do we get here? It will come equal to sine A minus B, sine A cos B, minus of sine B has become sine minus B become minus sine B. So what will happen when we have formula for A minus B, this plus sign will become minus. This can easily be arrived from the same formula. Can we do similar way for cos A minus B? So that is something you can try do on your own, and you should get this value. Cos A minus B, this term will not change. Only thing what will happen, the sine minus B term will become minus sine B, minus this becomes plus. So what happens, the sign of this term has changed. Plus has become minus here and minus has become plus. What else we can do from these two formula? Even sine 90 plus theta. Can we find sine of 90 plus theta? Yes, we can again have similar expansion. Sine of first angle into cos of second angle plus cos of first angle into sine of second angle. Well, basically two terms here. So this is how we can write here. Now we can substitute value of 90. Sine of 90 is equal to 1 and cos of 90 is equal to 0. So this term will vanish and this will become 1. So sine of 90 plus theta is equal to cos theta. This also can be arrived from here. And this also important relationship which is often used. Similar way, sine 90 minus theta. We also calculate what is sine 90 minus theta. Same way, same formula will apply. Only thing in place of plus, it becomes minus. Again, we put it, we find it, again, it's equal to cos theta. So sine of 90 plus theta is equal to cos theta. And sine of 90 minus theta also is equal to cos theta. What does it mean? So it means, suppose what is sine of 120? Suppose I have to find sine of 120. There are two ways of finding a sine of 120. The sine of 120, we know the values of angles only between 0 to 90. So what are the angles for which we know the values? 30, 45, 60, and these are and 0 and 90. So this, I need to write this angle in some known form. So one way I can write as sine of 90 plus 30. Other way I can write is as sine of 180 minus 60. So these are two ways I can write as sum of two angles or as a difference of two angles. So when you have sine 90 plus theta, that's what it says. What this would be equal to, in place of theta, we have 30 degrees. So it will be equal to cos of that angle. It is equal to cos 30. So sine of 120 is equal to cos 30. And we know the cos of 30 will be equal to root 3 by 2. So that's how we can use this kind of relationship. Similar way, I could have done other way around. Sine of 180 minus 60 is equal to sine 60. We have done second quadrant. Second quadrant, so it remains positive only, and sine of 60 value is equal to root 3 by 2. So either we calculate, we come to something same number. And similar way, you can do for 90 minus theta as well. 90 minus theta is equal to cos theta. And sometimes we need to find angle of twice the angle. So suppose I have to find what is sine of 2a. To find 2a, how do you get this equation 2a? In place of b also, we substitute b is equal to a. So we substitute b is equal to a. So in this equation, if I substitute b is equal to a, left hand side will become equal to sine of a plus a and equal to sine of a cos of a plus sine of a and cos of a. It will become equal to 2 sine a cos a. That is the formula for sine 2a. Similarly, we can get it for cos 2a also. For cos a plus a also, cos 2a will be equal to what? Again, wherever b is there, we substitute a. It becomes cos square a minus sine square a. It will become equal to cos square a minus sine square a. And it can be written in different form using cos square a plus sine square a is equal to 1. I can either write cos also in form of sine, or you can write sine in form of a cos. So these are the, you don't have to memorize. What we need to memorize are these two. And once you memorize these two, there are a number of other formulas can easily be derived, easily be arrived at. Within few seconds, less than a minute, we can get other values. So cos 2 is equal to cos square minus sine square a. If I write in place of sine square a, 1 minus cos square a, it becomes 2 cos square a minus 1. And or we substitute cos term in terms of sine, it becomes 1 minus 2 sine square. So these are some other trigonometrical formulas which we need to use. So in addition to value of angle, in fact, value of angle also not much to memorize. If we remember those triangles, 45-degree triangle, 30 and 60-degree triangle, we can get those values very quickly if you get a mental picture. But these two formula is something you need to memorize. These two formula, there's no intuitive way of explaining this formula. This formula needs a little slightly complex derivation. So this must be memorized. Let's move on. Okay, angle in radian. I think angle radian, we had dealt with angle in radian. What did we talk about? We are going to this one more relationship very commonly used in physics in several derivation when angle theta is small. Now, so when angle theta is small, the value of theta is almost equal to sine of that angle. Let's understand what it actually means. So this kind of substitution, when theta is small, in place of sine theta, we substitute theta itself. And that's the reason, and this kind of relationship exists only when theta is in radian. That's why in physics, to use this kind of relationship, we use angles, normally we use angles in terms of radian. Let's understand why does it happen. So to understand this one, radian is in form of an arc of a circle and radius. So something like this. So here also what we have here is AB is arc of a circle, R is the radius here. And this is, if angle is small, it is a small part of the circle. Two ends of the circle are connected to the center, and this angle forms theta in radian. So if I want theta in radian is equal to length of the arc divided by the radius. We know that part, so we are going to apply that knowledge here and understand this point. So you understand? So here we are not trying to prove, but we are trying to get an understanding where from this relationship comes. The figure, what is theta is equal to? Theta is equal to length of the arc AB divided by radius R, which can be R radius can be OA or OB, both are equal to R. That is value of theta. So we have arrived at the left hand side. So left hand side can be written as length of the arc AB divided by OA, let's say OA or OB, any of these two. Okay, can we write sine theta also? This is angle in radian. So what will be sine theta? How do we get the sine theta? Sine theta, we need to have a right angle triangle. So there's no right angle triangle. So what we do here, we drop a perpendicular here. Okay, so I think the perpendicular drawn later here. From here, we drop a perpendicular on this side. Now there's a right angle triangle OAM with the angle being theta here. What is sine of that angle? Sine of angle is equal to opposite side divided by hypotenuse. So what is opposite side? AM is the opposite side here. So what is sine theta? AM by R. Okay, so now we compare these two. So theta angle is length of the arc in the numerator, and sine theta is the length of the perpendicular. So there's a blue curve and there's a kind of orange color line. When theta is small, you notice the length of the arc and length of the perpendicular are almost equal. For a small angle, length of the arc is almost equal to perpendicular length. If this value is almost equal to this value here, then theta is almost equal to sine theta. Only thing what happens, theta need to be expressed in terms of radian. Then only this relationship is valid. What does small angle mean? So just to understand this point also, so I made some kind of table. So let's see. Let's compare these two values. See, it's an approximation. Any approximation involves errors, and understanding error also is an important part of learning physics. So let's understand in this example. So whenever we make this approximation, what is the extent of error involved, and how do we calculate? So let's do that. So let's say different angles. So I'm taking different values of angle. So first we understand angles better in terms of degree so far. So I'll take in degree, then I'll convert into radian. So what are the angles? Let's take example of 5 different angles. Angle of 5 degree, 10 degree, 15 degree, 20 degree, and 45 degree. And how we convert, and since we want to have compared these two values, I need to convert this angle theta into radian. What is the way to convert per degree into radian? What are the relationship in recall? We had what is 180 degree equal to? 180 degree is equal to pi radian. No, so wherever, so this is how the conversion we do here. So suppose I want to find 5 degree. For 5 degree, so basically from this equation, what is the degree equal to? Just look on from here. What is degree equal to? Wherever degree is written, degree is equal to pi by 180 radian. So let's do, I have to find the value of 5 degree. How do I convert 5 degree into radian? Where a degree is written, I'll substitute this value here. And this is a method we can use for any conversion of units. So 5 degree is equal to 5 into pi by 180 radian. And if I calculate this value, it comes equal to 0.087. This is the radian. So 5 degree is equal to 0.087 radian. Similarly, 10 degree will be twice of this, 15 degree will be thrice of this, because it's a linear relationship. So all angles I have calculated theta in radian. And we can, from scientific calculator, I have also calculated sine of 5 degree, sine of 10 degree. All these values are actually sine of that angle. This is calculated from the using calculator. Now let's compare these two. What we find here for 5 degree, what is the extent of error if we take up to third decimal? Up to 5 degree, error is 0. Error is actually the difference between these two numbers. If we take these two values equal, what is error we are making? Now we find error is 0.001. True value of sine theta is 0.174. If I take sine theta is equal to theta, I'm in place of 0.174, I'm substituting 0.175. So error is 0.001 from a true value of 0.174. So this error I can calculate percentage error. What is percentage error? Percentage error is error divided by true value into 100. So when I make this approximation, I have taken even the 4th decimal place also. So up to 5 degree, in place of sine theta, if I substitute theta, error is only 0.1%, very small error. Up to 10 degree, error is 0.5%. Even up to 15 degree, error is 1.1%. But if I take 45 degree in place of 45 degree, which is equal to 45 degrees pi by 4 radian, which is equal to 0.785. Here the error becomes 11%, becomes significant. So you notice here, if we want to restrict the error to within 1%, This kind of approximation can be made up to an angle of almost 15 degrees. If the angle is smaller, the approximation is more accurate. If the angle keeps getting bigger and bigger, this error keeps increasing. If our tolerance, if we are okay with the error of 1% up to about 13-14 degree, the difference between the two values only about a percentage. So this approximation, the reason being, for a small angle, the length of the arc is almost equal to length of the perpendicular. And this substitution also we make several times in physics, in first year as well as in the second year. So this also a small part of trigonometry, and we should have some idea. And we also introduce the concept of error. And whenever we make approximation, we should understand approximation always involves some small element of error. And we should know where the error comes from, what is the extent of error, and to what extent we can make the approximation. So this approximation is pretty good up to 10 degree, no problem at all. So that brings us to the end of trigonometry part. Next session, I will take the next topic, which is slope. So I'll stop here. I hope all of you just go through, revise this multiple times till it has gone into your permanent memory bank. Thanks.